So matplotlib.pyplot, and we use here PLT, is like a MATLAB-like plots, and here the same. And this thing is for rendering. And from mass import cell, we also need to obtain the ceiling value. So for element stiffness matrix for mechanical analysis, here in this code, we define a function KEC, and this value, the first thing you need to define the KE, you have to obtain the KE for any topology optimizations, and then you will go for the finite elements sections. Okay, let's delve deeper into the topology optimization world. So first, I want to mention that in these lessons, I just wanted to emphasize how to use machine learning for predicting the sensitivity functions. So I will tell you step by step how to predict the derivative of a simple functions by machine learning, and how to tune the parameters, and then we will apply to any topology optimization. But I will also, in the future lessons, I will also help you guys how to tune the parameters for complex system. So I have x dimension and y dimension, which is 1 and 1, and I will define a function. So here I use def. For any function in Python, we use def, and then we will put a name, and you know that for any function we have to use parentheses open, and since we have an input, we have to have x. If you don't remember anything about Python, please also watch the video of 5.5 hours of Python. I will put it on the description. So I said that here we return x squared. So here x should be an array, and this means that you know that for any array, it acts like a matrix. So it means that the first column, which is 0, and all of the rows, so we just get the first column, and we reshape it to -1, comma 1. I have to talk about this part because most of the students forget about this part. Let's talk about first stats.qmc.latin hypercube. Stats is related to statistics module, and QMC is quasi Monte Carlo, and Latin hypercube is the functions. If you want to get some pictures in your mind, you can just have this picture in your mind. This is a grid sampling options, random, Sobol, and Latin hypercube. So as you know, when we have stats, it means that from SciPy I import the stats as stats. I want to keep this here, and then I don't need to write SciPy dot stats. I mean, like this. You don't need to type this in because you will get an error. So the reason why this is not correct, and there is a trick in Python. Remember, when we say that from SumPy import blah 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 as blah blah blah, you should always start from this. I mean, so you should remove these ones, stats.qmc. blah blah blah, and then it works. Okay. So, okay, now we want to get the same results, but we want to put here QMC, but we need to change this one. So it means that we said from SciPy dot, so stats import. So which one? You will see here, QMC. Okay. And now we type here, we copy from here, QMC, blah, blah, blah. Done. It works again, the same results. Okay, you might ask me why didn't I put as QMC? The same result again. It doesn't matter. Okay, now you might thinking, can we also type like this? Dot QMC. Is it possible to use something from, for example, here I copied this one and I said dot QMC. Import Latin hypercube, and now I just have Latin hypercube. The same result, 3 methods, 3 ways. Okay, now I will just keep all of them in the same line to remember these ones. I will also put this one in the video descriptions. And okay, all of them are the same. Of them are give the same results. Same result. Okay, now let us get back to the model. If we get a model from anyone, so okay, first we need to import h5py module. And what is h5py? It is a hierarchy or hierarchical data format version 5 py. So you just need it for opening your model that you saved. So if you have a .h5 model, you need to import this one first, and then use the TensorFlow if you want. And again, you can load the model using TensorFlow with this model. I insist on using model as a variable name, tf.cross.models load underscore model. This is the method for, and this is better to use the absolute pass. And print summary, you can see your neural network models. So 2 things. You have hierarchical HDF and version 5 actually. For a large amount of data, you use hierarchical data format version 5 file. So again, first import the h5py and then use absolute rules, not local one. Some people just use this. For example, this is the name of their model. For example, the neural network model, density-based topology optimization, and this is the number of the element or features, and that's it. You want to open this one. And remember, when you are using the pass or you want to copy, it is forward slash. Like Linux, I'm using Windows, for example. If I go to here, it's backslash, so you need to change these ones to forward the slash. Okay, I will also type this one, change these two. Forward the slash to backslash. People use MATLAB code or whatever. So yeah. And then model.summary. Another important point, when you are using the high performance computer, it's better not to have a path like this. It should be underscore. It's better to have underscore here. It is not professional to use this. Yeah, I made a mistake, but it's a local machine. It works here. Okay, before going further, first I will here we need to numpy.mathlib is like the MATLAB like functions such as zeros, ones, methods such as I, rand, these ones, and also SciPy as I discussed before. Okay, SciPy here is used for importing SciPy library. SciPy is a Python library that is related to scientific. Comes from the scientific and technical computing, and such as minimization, eigenvalue, eigenvector. Okay, this one is my favorite actually. CS from scipy.sparse, we have a compressed sparse matrix or compressed sparse column, and this is a COO matrix. It means that we will give the rows and then column and the values. This is also my favorite. SPSolve is for solving a system of linear equations. So you suppose that you have a 3 by 3 matrix, which is A here, as you see. Then B is the right hand side, and you want to find the X.